So the next point is the projects. I really need to know how many people would like to continue on their projects, and the earlier you can decide, the better it is for you. And we can think of, I put in about 8 projects in here that you guys can think of from and pick up, because these are real problems, and where you'll be able to actually, when you'll provide a solution, you'll be able to find other solutions that they exist, and then you can compare what kind of functionality you came up with yourself. So this is why I want you guys to think of real life problems that you may face 3 months down the road when you look for a position. Now you may be asked to be on a project where knowledge management solution is being built, or an intranet for a company is being designed. And that is where, when you stand in front of an architect, you can talk to them intelligently because you have thought about that problem before. So this is something that you might want to keep in mind, especially here. It is not to give a web-enabled solution for this project. That is not the idea. The idea is to actually think about the problem more before you give a solution. So,
do you want us to code these projects?
At one stage, yes, but that will be in the 3rd week. If you look at in the week 2 and 3, that is when you will be actually writing the queries, because you want to do the performance tuning. You want to have the confidence that if somebody gives you that, okay, this application is running slow, you should know where to actually start from. That is very, very important, rather than at that time start looking into books. And so that is what we'll actually converge at, because I think if we can get that kind of confidence out of this class, where you can improve an existing application or suggest an intelligent solution, that's more than enough. It's really enormous addition you can do. And in terms of using database, it's your choice. You can use whatever database you want, and Oracle would be useful in the sense because explain plan commands and the commands with which you can actually do the performance enhancement and measurement are very well documented. So I don't know if somebody, if you try to use some other database, it is fine to explore, but make that decision after you find out that yes, there are these utilities there, that those interfaces are available with that database to actually do it. So just a heads up, before you start working on queries, think what platform you want to use. Okay? And if you guys, Rusty had told me that some people don't have Oracle on their machines. Are there some people who, because the BRIOS were taken away and people don't want to install Oracle on their black boxes? So, are there any?
I don't currently.
Okay, so Rusty suggested we actually have 1 or 2 computers that we can make servers, install server on it, so you can log in, because all you'll be doing is very simple SQL query writing and actually doing the
machine in this room was already set up as a server that has Oracle on it for the April month.
Is that?
Did anybody
that,
use that machine? Yeah, a couple people did. So that.
Okay. That's fine. That's enough then. Okay. We can put some more RAM on it if needed. Okay. Any other questions about the course structure? And about one, oh, sorry.
If we don't want to do our project from 2 months ago, whenever it was, are you going to provide us with suggestions, or you're? These are
the suggestions that I could come up with.
Oh, I see, in the middle there. Yes.
Sorry, I should have highlighted it. So these are just these are the things that, while working at AD over a year and a half time frame, these are the things that I have seen people trying to look for intelligent solutions for, and these are real problems that exist. So, just suggestion. I mean, if you can come up with a better one, that's absolutely fine. Okay. Regarding recitations, this course is a very subjective course, and so there is a lot to learn from it, but a lot of information is actually something that you actually want to remember. The jargon, it's like learning physics, starting to learn physics. You have to understand what term velocity means before you go to the formula for velocity. Okay, so what we are going to do in this course is actually understand why do we need relational calculus, then go and use it, but then come back to SQL. Okay, so a lot of things that you will see are you just want to understand and remember terminology so you can appropriately explain a problem to a database guy 2 months down the road. Second is in recitations, that's when I decided that we should actually include discussions about problems where database managers are becoming very, very important part, like this Human Genome Project. If you cannot write intelligent queries, all this data is useless.
Which project was it?
Human Genome Project, where any project where you have a lot of information, that is where an intelligent database programmer can make a difference. So I'll try to see if we can pick up some such good problems and pick up some reference material for discussion. We'll come to the recitation. Beforehand, we'll give you these articles, research articles, and discuss the problem that they are solving. Why is it such a complicated problem, and what kind of solutions people are proposing. Another very big problem is pattern matching, where you have a huge database, and then you have to do pattern matching and coming up with a reasonable solution. So these things where database is a part of the problem, but then over the years, because those problems became very well defined, now database part is becoming more important as we collected data into that thing. So we'll try to come up with some problems that people are trying to solve. Okay, let's go on to why do you need a database, what is a database, and what is a database management system. So what you think of a database management system is that you have a database, and then it has to actually provide the solution to talk to this database. Okay, this becomes then DBMS. Okay, so this is what was come up with when the problem started happening with file management system, regular having files instead of databases. You can think of file storage in a way when you go to a grocery store. Okay, in a grocery store, either you can have an aisle for every recipe, or you can have food items classified according to some common attribute. So file system is where you add a new recipe and you have another aisle. Okay, what problem occurs is that the same spice is being used here. Okay, so extreme redundancy. So to avoid this thing is what the relational databases came into play with. Okay, what you want to have is you want to have at least a defined relationship between the attributes of each object that you are relating them. Okay, so if we look at the file structure, let us try to compare them more critically, because interesting, both sides. Okay, when you have a file structure, how do you actually control access? Okay, all you can say is, okay, I won't give permission for this person to see this thing. Okay, there's no granularity in the access control. You cannot say that, okay, user A can see this part of this file, and user B can see this part of the file. Okay, this became a second problem. Okay, because you want to, so again what you will end up doing is, okay, let me make another file that user A can see, let me make another file that user B can see. So where do you stop? That is where the crux was. Okay, you'll keep on having redundant data. Okay, same thing started having if you think of concurrency. If the two users access the same file at the same time, how do you control who does the transaction? or when the transaction occurs. So all these problems were coming, but because the management, or I should say the amount of data that was being handled was small enough that you could still think of it like this. This was earlier years. But now everything moved into to provide the solutions for granularity. This is one very big aspect that you have already realized when you can actually make views. I'll come to it in detail. Because this is what gives you suddenly that you can create in a database, you can create user-based views of the same data. And that is where you start classifying without any redundancy who will see what and how it is going to be presented. Okay. So now let's think of data abstraction. One thing you should realize, that's what I was talking to Rusty yesterday, is that SQL has evolved after programming languages. And so as anything evolves from a matured platform, it is always evolving towards becoming intuitive. Okay, that is where the strength of any environment comes. It's like these Visual Basic started becoming totally a drag and drop, because it evolved over years. So that is what you'll realize with SQL is it's really intuitive, and that is why all the things that are done with database are also quite intuitive. So if somebody points out these things, they seem very intuitive at this stage, but not at the stage when they were being defined and the problems were being encountered. So let's think of the abstraction layers. So this is our database. Okay, there's another layer where you have physical, and then you have logical. And views. Okay, so now what you are seeing is that this database sits and it has a physical abstraction layer where all the implementation goes on. Okay, now there is a logical abstraction layer on top of this where you define the relationships. Okay, if you change this, so the two important things that you want to achieve from a DBMS is if you can make these two independent, that if you change the logical model and you don't have to change this, that is great. If you change this and you don't have to change this, that is also a huge improvement. So as long as you can give this kind of independence between logical and this one will always be independent, right? Because these are some things that people are just accessing them. So they don't even have to know how things are implemented underneath. Okay, so what you are doing is you are making selected data available to these people to view.
Give an example of things at those different levels.
Okay, okay. So now if you, I had actually put it in the image. I'll put it for everybody. Okay, so what we'll do is, let us think of this logical as where you define all the objects, their relationships. Okay, how they are related to each other. Here what you define is how are the indexes built. Indexes and what else will go in here? Because conceptual will take their, here the properties will also go in here, whatever the properties of the objects are here, and file structure will go here. So what you're seeing is that the objects and relationships go here, and how actually data is being implemented goes in here. So this is the physical implementation, and this is logical relationship building. So this layer does not have to know how these files are structured. Okay, because all you are going to do is you are going to use these relationships to actually build the next layer. Make sense? Is that okay? Okay. So you can think of all the constraints are going to lie here. Okay, all the relationships that are between the objects and their properties are going to lie in this layer. Okay. So now let's look at let's look at. So another thing is going to be how actually you can database access path is going to be defined here. So this is all the physical implementation to enable this. Okay? Okay. If I don't get any question, does that mean yes? Okay.
Where's the data types that something is a bar chart 20 or the database only understands?
Okay, so now that is, yeah, so those are now the structures. Right? So those are actually telling you how these variables are being implemented. Right? So they'll go into the physical layer. But if you define an object and its attributes, they'll go in the logical layer. Right?
Yes.
Okay. So now let's think of how actually. This is such a nice picture I made. Now you'll have to see the bad through my hands. Okay. So now let's see. We have. I'm going to break the database into two parts because here is our metadata information and here is our DB. Okay. And now here we throw in the queries. Okay, DBMS comes here.
Redefine metadata for us.
Yeah, so metadata is information about the data.
So like the table structures.
Yeah, basically, yeah, so that is what actually defines what actually is being stored here. Okay, so now what we have is, so these programmers write queries. Queries come in here, and then there is a metadata there. So let me just expand this thing up. What actually happens? So now what is going to happen is when the query comes in, I'll make these available again for everybody, and we can discuss these more. Then what it does is it goes to relational operators. Once it goes to relational operators, that it will go and define what are the access and then you have the buffer managers here. We'll go into detail about these things during the course of lecture today. But this is what is really happening when you throw in a query. Okay, I'll actually go even more in detail about what actually goes on when it hits the database also. Okay, when a query eventually hits the database, what kind of query plans are decided, what decides what execution plan should be used, and all those things. But this is really what is going on when you think of, so actually if I'm writing this as DBMS, this is actually a part of DBMS. Okay, this is where the query processing is going on. Okay, so now let's see.
So these are all outside of the database?
No. I just expanded this.
Oh, okay.
Expand.
I thought you dropped the queries into it.
Oh no, so basically all this is what is happening during the query processing. I should actually encapsulate this thing. Okay?
And we have the metadata and the database kind of unconnected to anything else.
Yeah, so what is happening is, so you have, so the DBMS software, the software part of this thing is what is going to interact here. Because that is, if you think of, okay, what is DBMS? DBMS is providing you with the engine so you can interact with the database. Okay, so it actually includes software along with the database. Is that better? You'll like the diagram when you see it later. I might have confused you a little bit.
DBMS is the software plus the database.
Exactly. Okay.
The database is mainly file structure and file system.
Yeah, so that is where you are storing everything in. So if you say, when you say you create a database, right? So you are creating the appropriate tables for it, you are creating, so that is actually your database.
Okay.
Right? Instead of thinking of it as file structure, try to think of structure of all these objects that you will define that will make your database. Okay? You guys have used the concurrency control and all that in all your solutions that you developed in Philip's course. Did you handle concurrent users? How would you actually, if one person is trying to access or change the information, would you lock it? Will you lock the object? So if you have implemented it, is good. Otherwise, these are the concurrent transactions and isolation of concurrent users from doing or corrupting the data is another very powerful feature that is integral to an asset database. Okay, so in concurrent user, basically, because why am I stopping is I'm not sure if I should actually go into detail with this or not, because I feel a lot of heads nodding that yes, they understand it. Okay, I'll say it.
One reason I was confused about what you just said is we certainly used a database which did that. We didn't implement anything like that ourselves.
Right.
So
No.
I don't know what
When you so there are two parts to it. Once you are doing a transaction, okay, you want to lock that object, I should say. That is the appropriate term. So if you are
right, which Oracle took care of.
Did it do it automatically?
no.
It didn't.
No, it is, you have to actually, that is where the transaction comes, right? When you say something like DB transaction or when you encapsulate, that is where you begin the transaction, right? So what you are doing is, let me just give an example of a shopping cart. Okay, you go to a website, right? And you say, okay, I want to buy this, you put it in your shopping cart. And then you don't buy it. What should it have done in the back? It should, even if there were two items left, it has to actually reserve one item for you, although you haven't bought it. Because at the time you put it in, it has to check the availability at that time. Now next two users, so now there is only one left in its inventory, and two more users come in. So this user gets this one. This is going to see 0 till you actually kill your session. Okay, so that is what is happening at the transaction level. So you can think of it as holding back, putting something on reserve. Okay, and these two are of two levels. Sometimes you will see, like you click on something and then that wheel keeps on rotating or hourglass keeps on showing you something. Is because, suppose this is the table, right? This is buying a car and this is buying a house. Okay, this is where, I mean, if you can buy online, so that would be the big, we are already here, next would be buying a house online. But if you think of this, you're buying a car, either I can lock this whole table till you abort or commit the transaction, or I can lock this row. So I think it was SQL 6.5, if I'm not mistaken. Don't hold me back on it. But one of these SQL editions actually had table level locking. So somebody could say, okay, let me buy this lipstick and just not go do something else and lock the whole thing. And somebody else could be just waiting. Rather than doing a row level locking, still it is bad because it has to lock the row. But at least rest of it is accessible to other people. Okay, so Oracle implements row level locking. So these are like subtle details that I think the SQL Server 7 already implements row level locking. This was one of the earlier editions that.
So like in these DB calls, when it was creating a handle, we were kind of told that, you know, like for an intensive thing, we had to release it, otherwise it would be locked.
Okay, so handle management is a different issue. I'll explain that to you right now. So what he's saying is, so there is a pool. Okay, there is actually a pool of handles that, if you guys remember the ini file, that you then specify how many handles and open cursors can be on the database that you open a connection. So you can keep on taking handles from that pool. But if you don't release them explicitly, there are two ways. One is, I think with time, if you don't use them, they'll be made available. But you can do an explicit release, because you should always do that. And do an explicit release as a habit if you grab a handle. That is where that thing comes. Okay? Okay. So now let us think of what overhead comes when you think of this transaction. So this is the database in state A. And you try to do a transaction. And when you do a transaction, you want it to go up to state B. And transaction aborts. You need to recover this whole state back. Otherwise, you have a corrupted database. So what you have to do end up in databases, that means you have to log this state so you can recover it back. Otherwise, you'll never, that is what, if you remember the rollback statement that you have. Okay, so this is now, that means these log files become much more important when you think of doing transactions. All or nothing transactions. Okay? So this is another part of the database that has come in. Okay. So now, oh, I thought there was a question. Okay. So let us look at, so this is basically an overview, and in the end again I'll take you through how actually DML compilation takes place, what are the components that actually make things happen inside the database also. But this is like the overview of why databases were designed and the different parts of a database. So now let's look at how SQL got in, and that was, I don't know, I was surfing the website of the author of this book, Ramakrishnan or something, and their department said that E.F. Codd, the guy who actually defined SQL in 70s, was in their department sometime. So that was like the top guy written that our alumni, he got equivalent of Nobel Prize for this, I think it is called ACM some award for. Yes. No.
The IBM guy who created the relational databases.
Yes. So he was caught, I think he got it in 83. He started off in 70, but he got the award in 83 or something like that. This intelligent guy. So let's think of SQL. Okay. So the structured query language came in, and in essence what it has is you have DDL, DML, and then you'll have DCL, data control language, and very self-explanatory terms. So here, all the commands that will be used to define, like create.
What do those stand for?
Data definition language, sorry. I'm sorry. What I'll do is now, I actually took, I think, quite a bit of SQL for granted because I'm realizing in our discussions. What I'll do is I'll try to point you guys to a tutorial also. I think there are some really good tutorials available on the web. Just to be familiar with the jargon even, what kind of terms are being used if anybody wants to go through it or something. I'll look for it tonight and I'll spam you guys. So now in manipulation, what you will have is all the update. So I tried to actually collect all the different types of statements in the handout that you have, and update, insert, because what you're doing is you're actually manipulating the data here. So here you are doing the definition in creating and of the objects. Okay. Okay, so now the SQL actually implements set theory fundamentals. All the returns are in terms of sets. Okay, it will be a selection of set of some type, or update of a set of values. Okay, so that is once you actually do a selection or any I should say manipulation or definition, not even definition, but manipulation of any object or its attributes is when you start using the set theory fundamentals. And that is why when we go to the next chapter where we'll define the ERDs and relational calculus, and that is where this relational calculus will actually come into, and it is a prelude to actually having an SQL. SQL actually builds on top of relational calculus. So when you say a join, that is actually the join that we use in set theory of tables when you do that. Okay, I'll go into detail when we come to that. I don't want to get distracted right now. So now, another important aspect is for the rollback is that you can have a save point. So a save point is that you can actually define till what time it will roll back. So you can have a transaction going on, and you can define a save point A here and a save point B here. Okay, if you did not define and here it aborted, suppose here it aborted the transaction, it is going to kill the whole thing. It will not roll back to the point where actually this was successful. So you can actually here, a combination of rollback to the save point, you can actually define and say, okay, if I don't complete this, roll back only till this point.
Is that the same functionally as nesting transactions, or is this
No, it is because you're doing only one transaction, right? This is a part of the same transaction, but you are telling it. So if you think of this as you are actually creating like steps in this whole transaction, so you can tell it that at certain times there may be a lot of overhead just doing 10 different transactions, right? So what you could do is that, okay, if out of these 10, after every I should say event, I could actually define that as a save point. If I kill here, I want only to go up till here. Okay, this is in the case when you have a lot of events in the same transaction.
So you mean it might have been successful in building up the shopping cart,
Mhm.
They're bored, so you want to go before they even started.
Yeah, something like that. Or you might, or you could, I'm just trying to think a good example for it. Let me think. Or something like if you added, in your bank account, you added your salary check, and then you decided, I want to actually do, to take out money for mortgage. But maybe that month you didn't want to pay mortgage. Or something. All I'm saying is if in one transaction, just think of it, it is useful only when you have events in the same transaction. Because what you are trying to tell it, when you abort, go back to a certain point. Don't leave. If you actually did 9 transactions successfully and the 10th one aborted, you would end up redoing this whole thing and a lot of overhead in terms of resources. Because then you will come back and do it all 9 again. It is better?
So you need that's the point of the 2 save points.
Exactly.
So when you write specific stuff, it's Oracle. That's what.
Yeah. I'm picking up Oracle as an example because Rusty told me everybody had Oracle on their machines before. And we all got Oracle's personal edition also along with the book. So is that okay? Because I thought the whole idea here is that
It doesn't matter. Just let
Okay.
you know, like,
Okay.
you know, what it is.
Sure.
It's just the-
Yeah. Okay. Okay. So now let us think of what happens to the query when it hits a database, or when you actually issue a query. Let's think of that. So in the DBMS, when it comes, say a SQL query comes here. So first is it has to be parsed and validated. Right? This part actually goes into compilers and all that, but that is the first step it has to do. Okay? Then it has to do is, so what it'll do is that, okay, it'll parse it, validate it, and it'll give you some kind of intermediate form. That then is interpretable by the optimizer. Okay. So this optimizer has the task of defining, so the same query could be executed in multiple ways. The steps, I should say, internally it could be implemented because you could go to one table first, the other one again, or you could do in any sequence. So this has to decide what will be the plan. Okay, this is an important thing that you will be using for a few days when you'll do your query optimization. Okay, you'll actually invoke an explain plan feature, which will let you see when it hit the database, how much time it took, everything. That is where we'll get into the real performance tuning. Okay, because right now when you are issuing your queries, you're letting Oracle do whatever you want, or your DBMS do whatever way they want to do it. But later on in the course, we'll actually go and start fine-tuning our queries by, it'll tell you how many times it hit the disk. Okay, you'll actually do a lot of performance. You'll understand internals. I don't know how big a database can we have to actually see the differences in performance, but you'll actually understand what actually is happening. Okay, so that is what happens. So now, once this execution plan is decided, then you have to generate the code. Okay, to actually implement this execution plan. Okay, when the code generator comes out and it passes its handle off to a runtime environment. of the database. Am I obstructing your view? I'm afraid. Is it okay? Okay. Okay, so this knows how to talk to the database. Okay, so these are the things that go on when actually so we will try to see how much we can control to actually, or even go deeper into this process during the course of this course in the next 3 weeks. Okay?
Does the optimizer get some feedback from what the actual performance was? So that the next time it optimizes, it can say, ooh, that was a better decision.
That is interesting. I don't think it does, but I could be wrong, so I wouldn't say that. Because if that was the case, that would be, that is then self-tuning database. Okay? So Oracle 9i is just 2 weeks ago, actually you should see, we got Oracle 9i for Solaris, and AD is now the preferred partner for, or not, I shouldn't say preferred partner. It is all being recorded. Okay, so we are the partners for evaluating Oracle 9i. And I actually had the luck to do it and installed with our sysadmins on a Solaris system. And this is where they are actually introducing the self-tuning database concept. Okay, they're doing a lot more features in 9i, a lot more features. But they are actually taking care of, right now what you have to do is, if you are a DBA, you have to manage the disk quota and all these things as your database grows. It is a lot more things are being done internally now in 9i. So they are probably again adding another layer of abstraction on top of it and start becoming a black box.
Do you think it also might be self-tuning if it seems like it's having to recompile a certain query a lot of times? It would say, I should cache
No.
this.
How would it actually know when to recompile?
Just by observation. I mean, it sees, if it somehow keeps track of everything that's been going on, it just would notice
Could be.
irregularity.
Could be. I'll dig more into it when we come to this subject. But that is what 9i is now coming to in terms of, they must have, this is a very, very difficult part. If you can have a self-tuning database, you have a huge leverage. Just understanding, or just imagine how much it adds to scalability. The query that was written 10 years ago was probably good when 10,000 tables or 10,000 objects were there. If it is a self-tuning database, you go to 1,000,000 rows and it may change the execution plan. So scalability becomes enormous if this is implemented correctly.
If not, it'll be Oracle too.
You had a question?
It was probably answered.
Okay.
I guess you can compile these queries and then sort them.
Why would you want to do that?
But just for speed, so you have to go through this every time.
So there, what you're doing is you are talking about stored procedures type of thing. Is that what you're doing?
Well, already processed queries, not just Don't databases do that?
Let
Say
me
you can't just
think.
draw customer records all the time. It's just the same query all the time.
You're talking, is it caching or is it, so that is the question. Because it doesn't know, till it hits here, it doesn't know what it is going to do. Right? When it is hitting a query, is all it is doing, it is not thinking here.
So you need to put it in.
I would think so. I would think so.
It's not really the code generation that's taking the majority of the system resources, is it? It's the actual database lookup once you've generated the database
The
query.
plane, yeah. Basically, once you have, I don't think this is a big
So that
headache.
part you could cache, realistically, couldn't you? Because the query.
If you know that you're going to use it, probably it could, yeah.
But that's not really going to save us that much because we're still going to have to do the database lookup.
Yeah, what you have to think is that the biggest bottleneck is going to be a bad execution plan. Because that is where if you don't have a good execution plan, you don't have, I mean, this is not eating up your time. Okay, this is a translator. It doesn't do anything intelligent. Because whatever execution you plan have is what is going to kill this. How many times do you have to hit the database? Okay. Okay. So let's see. Another very interesting thing that is there is embedded SQL. So generic SQL gives you a lot of power. I mean, it is there. But a lot of power comes in if you can embed SQL. So you have a C code going on here, C program. And here if you can add SQL query. And then you can finish your C code. Because here, this part could actually provide a lot of GUI interface. And then you are able to do your SQL also through it. This actually adds a huge extensibility to usage of SQL. But the biggest problem occurs, you define variables here. How does SQL interpret them? These are different variables, different data types. If there is an error in SQL, how do you actually communicate back to C program? Error codes. Okay, why did this SQL not work? So a lot of work has gone into, and now, so a language in which we can use an embedded SQL is called a host language. So like ODBC, Microsoft's ODBC, open database connectivity. This is all written in C, C++. Okay, but it lets you talk to databases. Okay, same thing is with JDBC. Right? Embedded in Java. So Java database connectivity. All these are very powerful extensions of using SQL inside a host language.
So what do you call like an AOL server with those tickle libraries that have those DB calls? Is that?
No, so that is a little different. What does then tickle need? Tickle need, it is not compiled. It needs an interpreter only. Right? So AOL server has a tickle interpreter. When it hits that tickle code, it invokes that is why you have to actually do something like this, right? Because it knows that, okay, I got this square bracket. If I get something, I have not forgotten tickle, I can't believe it. Okay. Set. Great. So it is going to, the moment it hits the square bracket, it is going to invoke a tickle interpreter and expect a command that tickle knows. That is a little different. Because here, if you think, I'll just step ahead because he pointed it out, but what you have to think is that when something like this is here, you need to break this apart before you compile. Because the host compiler can only do this part, right? But the DML compiler can do this part. So whenever we have application that is written in a host language, that means this has to go through a pre-compiler that will break these two. Okay, it'll break. This should be served to host compiler. This will be to DML compiler. Now this object code is generated for this. It has to be recombined here again, link it, and then send it back to our runtime environment. that runtime environment, it will talk to the database. So this is what it has to do this.
So the embedded concept doesn't really survive when you have an interpreter, but there still has to be that linkage somehow that's mediated, right?
I missed your point. Can you say it again?
Well, somehow, I don't know whether it was with AOL server, I guess it was, because we weren't using ACS in our project. You know, the Tickle has these commands that are also written in Tickle, the DB ones, that talk to the Oracle drivers. You know, I don't really know what's going on, but some kind of DML commands, for instance. So there still has to be that interface there that separates.
No, and so what you have to think is with a regular. So let us think of a Tickle page. Okay, let's start from there. What is going on? It encounters HTML. It keeps on going. It hits the SQL Tickle command. It says, okay, I need to hand it over this to Tickle interpreter. Now it finds this command, say set command. It substitutes its values, and we instantiate some local variables which take on those values, and we continue interpreting it. So in that, it is just handing off control to the interpreter for that time being and bringing it back in. That is that kind of, so that communication is a little different that is happening in terms of having an interpreter than when you have, this is actually inside the database that is happening. I mean, to the database that is happening.
So what happens when the Tickle interpreter hits a SQL query? How is that handled?
Okay, so Tickle interpreter does not hit a SQL query, right? So
that point in the Tickle page actually comes.
Right. So it say you call whatever it is, say AD underscore header, right? So now, and you give it, say, certain thing, okay? Or you do a DB transaction or whatever you do. So if
something with the database.
Yeah, something with the database. You define a SQL and then you say even a select from the database, or do a DBDML and all those commands. So all those commands are actually defined in the library. Remember, there was a directory before www where you will define all your Tickle procedures, because at the time AOL server starts up, it knows all these commands are available to be interpreted. So still again there is, so what it is doing is when you invoke those DB transactions, they actually go to talk to AOL server, the Oracle driver, which is defined in our ini file, that okay, where is that driver located? Because driver has to do the translation of what is to be done to the SQL to the database, right? You pass the string till it is translated. It is a string, right? We actually say this, right? But then that driver has to do its job before it hits the database to actually tell it, no, this is really a SQL command. Is it clear? We can discuss later on also. We can actually pick up an example and go through the whole thing if you want.
So the idea of the embedded SQL is different than the ODBC type, or are you saying embedded SQL is? You're saying those are the same thing?
Yeah. So ODBC is an example, because here
ODBC statements aren't. There's no compiler for those. There's no DML. I mean this DML compiler, none of that happens.
No, so what you are saying is, okay, let's go in a sequence. I think otherwise we'll lose track of the communication. Okay. Let me start from what is an API. Okay, then we'll go to specific examples of JDBC and ODBC. Okay. So these are the standard APIs, are standard protocols, or I should say gateways that give you access to talk to applications. Okay, but these are well-defined standards, so you can actually use, say, give an example, you could use a JDBC driver to actually talk to something. Okay, translation being done. Okay, so let me draw a diagram for you guys. Okay. So what will the application do? It will request, and then it has to then submit the SQL. It has to define okay. So now this is the application. Now what you do is, let us go to the next one, which is driver manager. Okay, let's stop here. Okay, so now what is happening is that you wrote an application which makes calls to the SQL. Okay, this is a C application. Okay, it is like, if it is in C, for example, we could write something like this: exec SQL and something like that. So the moment it hits here, it knows I am going to get a SQL file. SQL command, not say file. Okay, so these are well defined, I should say, constructs that now C knows that I need to hand over the control of this part of it to the SQL or DML, whatever compiler has to go into it. Okay, does that answer your question?
I guess I'm confused about the idea of compiling, and when you're talking about preprocessors.
Preprocessor? Where is it?
Demarcation of SQL constructs for the preprocessor to recognize before the compiler for the hosted language is invoked. I don't know. I mean, these things are all just function calls.
No. So how does now C know what to do with it?
Calls a function.
Exec is not a function for C. It has to, all it is asking for is that, okay, now I know following this is going to be a certain well-defined. So, okay, let me rephrase what you're saying. Okay, instead of, it is not really a function, you can call it as a macro. Let us think of it in that format. That now somewhere it is registered. It's the same thing. It is somewhere registered that when you hit this, this is what you have to do. Does that make sense?
It does, but then that's different than what ODBC or what those other things are. I mean, ODBC are function calls. It's what we did. I mean, it's what people who use .NET, for instance, did.
No, that is to connect. So ODBC gives you only the connectivity to the database. Okay, it is. You can think of it as the driver part of it.
Right. Well, we can
Which will have a, but okay, let me finish this, because you raised that point, that again you have to think of that this connectivity has to come from a specific host language. That is why you have two different JDBC and ODBC. We'll go over it again if you want later on.
When you do this, you get a separate SQL file that's compiled, right, that you have to link with the other files.
Yeah, yeah. It's basically, yeah. No, it does. I mean, because you have to break it. Yeah, you have to break it. You have to break it because you have to interpret these DML commands, right? You have to. What I'll do is, let's wait till another page, and the diagram that I made for you guys, I'll draw it again on the board, and we'll discuss this more. Okay?
So it seems most likely you can do less stuff, right? To the database.
How would you talk directly to the database? Your interface is going to be just a SQL prompt.
But embedded SQL, you write commands for any kind of database, right?
Right. No, so you have to have so that is why I wanted to come here. With embedded SQL, this driver manager has to have that driver registered to interpret it also, right? Because what you are going to do is you are going to, in your application, suppose you wrote your SQL command, right? Some driver has to then go in and interpret that. So this driver manager is going to look for an appropriate driver that can execute your work.
Yeah, but suppose if you want to do something very specific towards Oracle, which only Oracle can do, but SQL Server cannot do. How do you do that then?
Okay, you're confusing two issues. One is, this is specificity of host language, not of database. So now this host language is deciding what kind of driver it needs to talk to, right? A C language, if C or C++ is the language. So what you are saying is that Oracle specific is totally different thing than this right now.
Yeah,
I'm trying to.
But it has to be translated, right? From your embedded SQL, you translate it to some Oracle command. But that embedded SQL could also be translated to SQL Server command.
Yeah, so it will have its own driver, exactly. So, say.
No, I don't know. It could be. I'm just saying. So it seems like some stuff you won't be able to really do with embedded SQL, perhaps. So.
Some, in what sense?
Because Oracle is different than SQL Server. So
right, so you'll have a driver registered for it, for Oracle, driver registered for it in the driver manager, because this is, driver manager will select what driver to use. Is everybody confused? I'm getting that feeling.
I think using the term embedded SQL is, I think we're thinking it's something different than what we did. Than what, that somehow it's a different thing than what we put in our web pages. And
okay, I think what you are confusing here probably is that what we did in our web pages, we used an interpreted language, right?
Well, not all of us.
Okay, so then I'm mistaken. Sorry.
Really
No,
anyway, the SQL isn't compiled no matter. The SQL isn't compiled in my compiled C# pages either. So the SQL is just left as a text string that's submitted to the database.
So what submits to the database? So what is happening is you have probably, so you wrote this page, right?
No.
It's an HTML page or with some different extension probably, so that request processor knows that this is the type of page I'm getting.
Sure, it's in C#, but it's just, it's like Tickle, it's the same thing.
Right, so it is a different extension, right? So that different extension makes a difference. Because if you have an HTML page with a Tickle command in it running on your server, it won't do anything.
Right, but embedded, I'm not trying to say this right. The embedded SQL is it's a SQL string that's an Oracle formatted SQL string, or it's a SQL Server SQL formatted string. It's not some different thing. Embedded SQL is just saying, we're taking SQL statements that are written in a SQL language for a specific database and embedding them in other applications, so other applications can access data from that database.
Right.
So now I'm confused, because then you need to change all your queries in your program.
Yes, you do.
To change the database. So where's the flexibility?
And that's true.
I think if you're using non-standard SQL.
Yeah.
No, if
You have to.
okay, let's rephrase the question. What is the question? What is question is what is embedded SQL? Okay, is the
I think I have some idea what people are confused about. Maybe is there a difference between what Tickle does when it sends a SQL query off and what JDBC does?
Yes.
Okay, and what is that difference?
Okay, so that difference is where what you have is you have a program or in a host language that needs to be compiled. Okay, now if this program needs to be compiled, then you need to actually, but this compiler does not know about all these DML statements. It can't compile them.
Which one are we talking about now? We're talking
The
about
first one.
JDBC, or we're talking about Tickle?
No, I'm talking about the compiled language, so it is C. I'm talking about C. Okay, let me start again. So we're talking about a compiled language. It could be C or Java, whatever language you take. Okay. Now what you do is you have SQL commands that are interspersed inside your code. Because maybe what you want to do is you want to show a form which you want to populate from your database.
But those SQL commands, are they specific to either SQL Server or Oracle, or are they like more
They have to be specific. If they are generic, that's fine also, but then the pre-compiler, right? So, okay, let me just draw it again, okay? I think it'll become clear now. This was an appropriate question. So allow, not to say anything else, but this is something I could get my head around. Okay, so let me do this, okay? So what we did was we wrote an application, okay, which has SQL commands embedded in it. There is some host language. For an example, let us take C, okay? You have C code, and then you have, say, SQL code, and then the C code continues. Okay? So now if we give this to C compiler, it is going to complain because it does not know what to do with this. So what we do is we hand it over to pre-compiler. Okay? Now this pre-compiler is going to break it into C code and DML statements. Okay? Now those, again, remember that these things have to be combined again later on. Okay? Now what is going to happen is the DML compiler is going to compile this part, and the C compiler is going to compile this part. Okay? And then these object codes are going to be linked and then served to the runtime environment. As one entity.
Okay, I think, okay. So my question is still, this SQL statement you have in your code,
Yeah.
is that specific to the database or not?
Okay, so let's go to that question now. Okay, so now you wrote this application. Now to do this, to work with this, you have to actually find the right driver that can do the translation also. Right? You wrote this, say, in SQL, in, say, MS SQL, right? Microsoft SQL code.
Okay.
So there has to be a driver that can interpret this. If you don't have that driver available to your driver manager, then there is a problem. But if you have all the other drivers registered, then it is not a problem.
Okay, so suppose now I want to change the database to Oracle. Where do I need to change that?
Yeah, you'll have to change the code.
I have to change the code.
Yeah, or if you can, or if there is a driver which is generic enough to take, and if you write a generic SQL, don't write a SQL which is specific to Postgres or Oracle or your implementation. If you write a generic SQL, but then I don't know if that driver is available. If that was the case, I think ACS would be running on everybody would write in that SQL. So you have to have an engine to interpret it. That is the thing.
What is in the driver?
I'm sorry?
What is in the driver?
Okay, so in the driver
contain the DML compiler for Oracle?
I'm sorry?
Does the Oracle driver contain the DML compiler for Oracle?
So the driver is interpreter.
Okay.
Okay, it lets you talk to different things. And that driver, depending on in what place it is sitting in this communication channel, it could be talking to two different instances also. All it is doing is letting you talk to. So let us, for an example.
Where does the DML compiler come from?
Okay, so DML compiler is a part of database, DBMS.
Okay. So the precompiler then knows to send the C code, whatever, to the C compiler, and then the DML down to the
Yeah.
database.
ODBC is.
So why is this like very powerful?
Okay, so what you are doing is you did this, you wrote this code. You want to say introduce. You have a code in which you want to have a GUI interface from C or Java, and then you want to talk to a database, right? How do you do it? Either you write two different things and then combine them in the presentation, right? Or you do it this way. So it is.
a system that works this way?
I'm sorry?
Is this a theoretical thing, or is there really a system that works this way?
I think the answer to that is it enables this thing. You can do it this way. You can use it.
I don't know of any C compiler that I could dump a SQL statement in the middle.
You're not compiling it to C.
Like,
You are giving it to a pre-compiler. That is a part of DBMS.
You have to have a special exec command.
Yeah, it has to, what you are thinking right now is compiling it as a part of C code. It is not a GCC or some,
okay.
right?
So if there is some tool with Oracle that I can feed a C program that has SQL statements sort of
You can enable, exactly. So you can enable this.
Okay.
I think that is what was the stem of confusion probably. So what it is doing is, let me just converge on this, that it is enabling you to use this. Okay, embedded SQL gives you another way to extend the SQL functionality. Rather than keeping SQL in a totally isolated environment, now you have the flexibility to actually, so I really don't want to distract you guys again back to the TickleAL server, but remember how powerful it became, that if you could embed Tickle inside HTML. Right? That's all I wanted to, as an example, I want to pull back in. That's all. But that is the idea in the sense. But because these are compiled host languages, that is why we actually need to split the two things, make sure that appropriate compilers get the right code, and after the object code is created is when you can do the linking.
So I guess the .NET, which you write in C# or C++, does this. No?
I have not used .NET, I'm sorry. We can look into it.
Even though it's
compiles
compiled,
to C#
Because it's just, there's function calls, and those function calls, you write a SQL statement, and that SQL statement is just stored as text in the program. And then when it gets to the point in execution, it sends that text string to the database and says,
What sense? What sense? There has to be a driver to do that, because a driver has to parse. I'm just wondering. I'm sorry.
ODBC is in between it.
Oh, okay. So what I'm saying is that there has to be something that will let you, and that is what I was. So somewhere it broke C# from the SQL, right?
No. It's just another function call. There's an object.
So you can think of then this, you will call this then a function. Is that what it is? You are preceding your SQL with something that this OS recognizes and takes it out, doesn't compile it with C#.
No, it does compile. It's just not.
Okay, okay.
It's not worth spending more time on.
Yeah. No, I think I can answer what you're saying. So what they have done is, you can think of it as well-defined macros, and because to begin with it knows it has to have a syntax in front of it. It can compile it. It won't do anything with it till it hits the database. All it is doing is it is doing a syntax checking. It is going to make sure, yes, the arguments for this procedure or function are appropriate, and leave it there. Okay, and then what it will say, okay, I know all I have to, or maybe it'll tag it at the time of compilation. I need to send this over through the ODBC and grab this thing.
Yeah.
So in a way, what they are enabling is the same thing, except of actually me calling it that it is splitting them. It might be just putting them in special quotes and saying, don't compile it, just do a parsing of error of argument comparison. Okay, it should get a string, it should have an integer as an argument, and just leave it there, as long as syntax is correct. And then we'll shove it over to OD. I don't know, I'm just, so I learned something about .NET today. Now I can talk about it. No, I will not talk about it. Okay, so is that okay? Next is I wanted to go into triggers or cursors. Shall we do it right now, or should we leave it for our recitation? Why don't I tell you why cursors are powerful? Cursors are powerful because if you think of a set of return values being returned in, say, 7 different rows. Okay, usually the languages like C and Java or all these standard languages, they are very well suited to handle variables, not groups of variables. Okay, so what cursors allow you to do is that you could, if you open a cursor and you get, say, 7 different rows returned from your select statement, using a cursor, you can loop through this.
So trigger and cursor are the same?
No, wait. Let's just, this is triggers on, sorry, cursors. So you can actually, what it is enabling you is to loop through each row and then work with it. Okay, so what it is, so now if you are doing just a loop in, say, a compiled language, to be able to actually work with it, you could start working with row by row rather than 7 by, say this was, so rather than working with a matrix of 7 by 10, it is actually looking at 3 variables only, step by step. So, I mean, and I'll have Rusty cover it more, a little bit more in recitation, but that is the power of cursors, where it lets you handle the things with
This isn't part of the SQL.
No, it is. No, cursor is another, can I call it a data type? I don't know what is the appropriate term for it. Cursors.
What language do you write these loops that go through the
SQL. So in SQL you can actually, it is like a procedure. Yeah, so what you're doing is you are returning a group of, you're getting a matrix instead of a single row. So you have to find a way to actually traverse through it. So that is what cursors let you do. Instead of getting actually appropriate term is data set, because instead of getting an individual value, you're actually getting a group of values. Okay. With triggers, I mean, you must have used it, but the biggest word of caution is, so triggers are anything that you, it's like a procedure that you define, but it has an event associated with it. Okay, so you can say that when you can do something like a, I should actually clean this up. Okay, so what you're doing here is you created a trigger called myTrigger before there is an insert on this table. Okay, so what you did was, this is where you defined an event that is associated with this trigger, and then you can, so here you can do a begin, and so whenever, so all this code that is following this will happen the moment this is the case.
Was it a create trigger or
Yeah.
execute trigger? Is that better?
No, create. You are creating a trigger. It is a SQL syntax because SQL has to identify it. So what you are doing is you are creating a trigger before insert on this. Now you say, okay, every time a new student registers, I want to make sure that registration has not gone over 10. Okay, let us assume that is the case. So what you could do is you could actually do do a select on your table, count the number of students, put it into a variable, okay, and if that, and compare it with 10. If it is more than 10, you could say begin and send me email or something like that. Send email, whatever action you want to do, so that I can close the registration. So what you did was you created a condition for it to execute. There is an event. Every time that event occurs, it is going to go and check if the number of students is less than 10. If it is, it won't do anything. But if it is 10, it is going to go and send me an email that yes, now the action has occurred. Okay, so there are a lot of ways you can use triggers. Is you want to make sure you can maintain data integrity with this. Okay, you can control a lot of things. But problem occurs when people actually start defining nested triggers. Because it is very, very difficult to actually trace nested triggers. You could be actually, if suppose this happens, you can actually call another trigger here, and it is very difficult to trace them and become memory hogs. So be careful, but our triggers are very, very powerful. Okay, it is like whenever somebody registers, you could send them a welcome message. So what you could say is whenever there is an insert on users, you could actually send an email every time anybody is registered or something like that. Okay, and you can do before or an after.
And that's
Okay.
stored in the database. So
Yeah.
It's permanent. until
Yeah.
you change it.
Exactly. Okay.
These can't be tied to rollbacks. You can't send a.
Sustain.
You can't tie.
No,
it
but
to,
no,
say,
wait. So
you're not registered.
rollbacks are a part of transaction, right?
So you can get the database back into the state it was at the last save point, but any email that you sent out, you have no confirmatory or. There's not a way to send another email saying, please disregard previous.
Rollback, you said.
The rollback just goes back to a snapshot, so it doesn't know about the time sequence of triggered events.
Let me think. So what you are saying is, okay.
Thinking about
No. Okay, not in terms of, because there is
So like
no
external action.
trigger does not have a timestamp associated with it.
But if you did an after, then wouldn't it fire after the transaction had completed? So you wouldn't.
No, you can. I mean, it depends on what you. If your event there is actually a transaction, you could do that. Depending on what event you define. And this could actually be an insert on sold goods, you know. That actually will happen when you have a transaction completed. That is when there will be an insert in sold goods, and you could do the same thing.
I think you have to treat them like side effects, basically.
Yeah.
That, it's a bang thing.
That's what they call the trigger.
Once it goes, can't ask for the bullet back. Okay? Is the pace okay? You guys give me some feedback. I mean,
Yeah, we just got
So-
stuck on that embedded bit. 'cause we hadn't done
no, I think it is good. I think, I mean, it is.